All right, functions from functions. We've been talking a lot about functions. Function, what's your function? All right, so we denote a function by calling it f of x. We give it a name, right? Yeah. Everybody, you remember this? Yes. Right. What? It's like y. That's exactly right. It's like y. But we could call it f of x. We could call it g of x. We could call it h of x. Those are the most common. But the point is, we give them names so that we can distinguish between them, okay? And so what we're going to be doing is we're going to be doing some operations with functions, okay? So we're going to define f of x and define g of x, and then we're going to do some things with them. So are y'all ready?
Oh, yeah.
Okay. I know. Because I was just talking about functions. I'm not talking about conjunctions. You got it? You ready now? Okay, I'm going to define f, g, and h. I'm going to say, let's let f of x be 3x squared. Cubed, let's do cubed. I'm going to let g of x be the square root of 4 minus x. And I'm going to let h of x be x squared. Okay, so I can do several things with these functions, and we're still on domain. We're not going to talk so much about range, just really domain. Bless you, okay? And domain algebraically as we go through this, okay? So looking at these two functions, I can maybe, let me change my color here. I can combine these with addition, okay? If I do f of x plus g of x, another way that I could write this is by saying f plus g of x. If you see that notation, that is the same thing, okay? That is saying just take the two functions and add them together. Now, what is f of x? 3x cubed. If my pen will work. What is g of x?
4 minus x.
Can you combine those two? No, there's no like terms there. There's no anything of the sort, so you literally just write it. This is f plus g of x. Okay, you do remember doing this? Yeah. Now, you've probably done this, Algebra 2. If not, it's okay. What we're also going to talk about is we're going to talk about domain for each of these operations. So this is, I should have labeled this. This is whenever we're adding, so the sum of two functions, okay? When we talk about domain, when we add, we have to look at the domain of each one of them. Okay, so looking first at f of x, what is the domain of f of x? Right, if you look at f of x on its own, 3x to the third, there's no radicals, there's no fraction. The domain is just negative infinity to infinity, right? Yes. What about the domain of g of x? Because it's a little bit different. What's wrong with g of x? It's a what? Look at g of x. It's a radical. Remember, two things are restricting my domain, fractions and radicals. I have one of them here, and that's a radical, right? So how do I find the domain of that function? You got close. If it's a fraction, I do the bottom to 0. If it's a radical, what can't be under the radical? A negative number. So I make it bigger than or equal to 0, and from there I solve, right? So subtract 4 and divide by negative 1. What happens when you divide an inequality by a negative number? Flip the sign. So what is the domain of the square root of 4 minus x? How do you say in interval notation x is less than or equal to 4? What's the smallest it can be? Negative infinity up to what? 4. Anybody confused? That's back last chapter, last test we took, right? Everybody okay on that? All right. So now, as I look at this, I need to combine these domains so that, because this is a combined function, right? It's still a function, but it's combined. So what would the domain of f plus g of x be? Exactly. Negative infinity to 4. Everybody good on that? I'm taking this really slow, but it's a really easy concept as far as adding to functions go. All right, do what? We're not graph. We only graph for the range. Domain we do algebra. Yeah. All right, let's go to subtraction, because these are going to get a little bit harder. Because I want to have F and G, and do y'all have it written down where y'all can reference F and G and H? Okay, then I'll just go to another slide. All right, let's look at the same thing, but let's look at subtraction or difference. That one was sum. Let's look at difference. Let's do f minus g of x. So we're talking about take f of x and subtract g of x. Again, you just write it. Don't make it harder than it is, okay? If there's like terms, you would combine them. If there's not, then you just write it. Be careful with subtraction, because when you subtract g, you subtract everything in g. So if it's got multiple parts, you're subtracting all those multiple parts, okay? So f was 3x cubed. G was, and what I tend to do is go ahead and put it in parentheses just in case there's multiple parts. Square root of 4 minus x. Now, I can't distribute that minus under that radical, but if this had more than one part, Olivia, if you put that away, please, then I would distribute that negative sign through to everything, okay? But since it doesn't, I'm good, and I am good just to write 3x cubed minus the square root of 4 minus x. That is the difference of f and g. Does that make sense to you? Easy, right? What is the domain of f minus g? Come on, y'all can do this. Yeah? Uh-huh. To what? To what? Yes. The domain is the same when we combine them. Okay, it's the intersection of the domains, and that's what they share. All right, let's do multiplication. If I need to spend longer on this, y'all tell me. I'm going to call it product instead of multiplication because we're a little more advanced than... All right, so if I have f times g of x, it's the same thing as, guess what? That's exactly right. Okay. Again, I know I haven't referenced it yet. I'm going to reference it when I get to composition. All right, so I am going to just simply write these out. Let's see, f of x was 3x cubed. And g of x was the square root of 4 minus x. And again, if there was something, if that radical wasn't there, I'd be distributing that 3x cubed through there, right? But as it stands, I can't do anything else with that, okay, other than multiply that way. So looking at this then, what do you think the domain is? Yes. 2. Yes. Same thing. If this one's negative infinity to negative infinity, this one's negative infinity to 4, then where they overlap or what they share is the negative infinity to 4. Okay? And you should be able to look at this and tell the domain of that on your own anyway, right? You only look for that radical, right? All right. Well, that domain is negative infinity to infinity. This domain is negative infinity to 4. So if it's left out of one domain, you have to leave it out of the other because you want what they share, what they have in common. So that's why you just go negative infinity to 4. Make sense? Like you can't have negative infinity to infinity because you can't let this be a negative under here. And now that's part of your function because you multiply them together. So you have to look, now when you find this domain, you have to look at this as a whole instead of the two separate pieces. What were you going to say, Jackson? Y'all okay on that? Because division's a little bit stickier. All right. Quotient means divide. So we're going to divide. Can you think of some way that your domain may be impacted differently as I do quotient? How? Because I'm dividing now. And when I divide, what can't happen? Can't have a 0 on the bottom, right? Regardless of what else is going on. So now this becomes 3x cubed over the square root of 4 minus x. I can handle the square root when I talk about the domain. I can handle the square root with it's got to be greater than or equal to 0. So that's where my negative infinity to 4 comes in. But what happens if you plug 4 in here? What happens if you plug 4 in for x on the bottom? It's going to be 0. So how do you solve that problem? How do you remedy that when you write the domain? How do you not let it be 4? What kind of inequality? So our domain before was this. Y'all can do this. How do I keep the bottom from being 0? What makes it be 0? What plugged in here makes it be 0? That's exactly right. He's doing it. He's doing the sign with his finger.
I can't get the word out. Where does
That says you can go all the way up to 4, but you can't actually be 4. Because if I'm actually 4, then that gives me 0 under the radical. Which is fine under a radical, unless the radical's in the bottom. Because the bottom can't be 0, right? You see what we did there? Say again? Because I can't let this bottom be 0. So if I plug 4 in here, 4 minus 4 is 0. And I can't have a 0 in here on the bottom. So I knew to do a parenthesis just to leave 4 out. Remember how before we were saying if there's a fraction, take the bottom, set it equal to 0 and solve. So square both sides. Subtract 4. Divide by -1. That tells me what x can't be. It says, hey, you can't be 4. So I knew to leave it out of the domain because I knew that this was my domain without looking at the fraction portion of it. If the equation was flipped and it was the square root of 4 minus x over 3x cubed, then the domain would remain the same, negative infinity to 4, the bracket. Okay, because it's still what they share. It's the domains they share, but then you also have to take into account, since I'm dividing, is there any value that's going to cause the denominator to be 0? And if there is, that's got to be taken out. Everybody okay on that before we get to the hard stuff? Okay, so f of x, the domain, was negative infinity to infinity, right? And if you think about domain is everything that x can be, right? G of x was negative infinity to 4. Since I've combined them into one function now, if I leave it out of one domain, I have to leave it out of the other domain too. So that automatically tells me now for my new domain, I'm going to have to leave out anything bigger than 4, right? And then I also have to look at when the bottom is 0. I've got to look at those two scenarios. So it's the domain that they share and then anything they need to leave out. Everybody okay? Let's compose some functions. All right, this again you should have done in Algebra 2, just not with the domain restrictions we're going to do. When you have a function, let's say I take my same f of x that I keep referencing. We'll use the same f, g, and h, right? Olivia, put that way, please. 3x cubed. If I asked you to find f of 2, what would you do? You'd plug that 2 in for x, right? You'd say, okay, well, this is 3 times 2 to the third power. Exponents come before multiplication, right? So 2 to the third is 8. Should be 24. What if I asked you what is f of y? It's just going to be whatever that, but with a y. So it's 3y cubed. What if I asked you what is f of x plus 1? And I'm making a point with this. The x becomes x plus 1. Everything else is still there, right? The point that I'm making here is whatever is in parentheses is what replaces every single x, right? Right. Are y'all okay on that? Okay. So whatever is in parentheses is replacing all those x's. So what if I asked you, y'all got that? All right, so what is g of x? Are we all in agreement there?
Yep.
So if I want f of the square root of 4 minus x, that means I take what f was, which was 3. It's not x anymore. It's square root of 4 minus x to the third power, right? Everybody okay on that? How about the domain on that one? It's still a domain. You still have to look at each one individually and do the intersection of the domains. Even if that radical were to cancel out, okay, by the end, like if that was a squared instead of a cubed and it canceled, you'd still have to restrict the domain because the domain was restricted in the beginning with one of your beginning functions. So what's the domain of f? Negative infinity to negative infinity, right? What's the domain of g? Right? So what's the domain here? Negative infinity, 4. Even though, no. Okay? Do y'all see that? I'm not going to delve too much deeper into that. I don't want to lose everybody. Then how about what is h of g of x?
Oh wait, I know it's so it'd be negative. root of 4 minus x squared.
It'd be, so h is x squared, right? So it'd be the square root of 4 minus x, which simplifies to what? These are opposite operations, so it's just 4 minus x. Now, even though that's 4 minus x, which is a linear function, my domain is restricted. Okay? My domain is restricted because my domain was restricted in G. Right? So what is the domain? Yes. See what I'm saying? You can't just look at this one and go, oh, that's a line. It's negative infinity to infinity, because you have to look at the functions, how they were defined to start with. Okay? All right. Sometimes we may write this as, instead of f of g of x and f of x, maybe I'll do f of x this time. It could be written, and I'm not sure how your book does it, a little symbol like this. Looks like fog. Okay? That's the same thing as, oh, sorry. Looks like I forgot I did f of x. Looks like that. Okay, the little circle, the little open circle like that means compose the functions. This is called function composition, compose them. So, what we've been doing this way. It's okay, it's okay.
So it'd be 3 3x.
Yes. Now, can you distribute that cube through there? Yes. When can you not distribute an exponent? What if it looked like this? Could you distribute the exponent then? No. Okay? When you're adding or subtracting in the parentheses, you can't distribute an exponent. But when you're multiplying or dividing, you sure can. So this becomes 3 times 3 to the 3rd x to the 9th. These exponent properties are coming back to bite you in the fanny. Same base, so 3 to the 4th x to the 9th. 3 to the 4th would be 3, 9, 27, 81. If you wanted to write that as 81x to the 9th, you could, or you could leave it just like that. What is your, okay. What's your domain? Mm-hmm. Exactly. Why is it not restricted here? Same function, and that function was not restricted in the beginning. Does that make sense? Huh? Yeah. Yeah. Because the only functions I was working with here are f of x, and the original domain was negative infinity to infinity. Let's change f and g and see what you can get. Let's see. These are some problems that look like your homework. And then I'll be done. I think this was a fairly, I feel like chapter 1 starts out hard, and then it kind of gets a little bit easier as we go. If f of x is x minus 1 squared, and g of x is 3 minus x. Okay? For your homework, they'll keep redefining f and g, f and g, f and g. Huh? Right now we're going to do addition, subtraction, multiplication, then I'll do some composition. Examples, yeah. Let's see. What's the domain of f? So what's the domain? What's the domain of G? It's a line. Exactly. It's going to be important for me to know the domain of each individual functions when I find their combined domain, right? All right. What is the sum of f plus g of x? Now, I'm probably going to need to expand this one out a little bit because I have some like terms here, or I will have some like terms, right? Can I distribute that squared through there? No, why? I'm subtracting in the parentheses, right? So I can't do that. So what I have to do is everybody's favorite thing, somebody said it, I have to FOIL. Try to contain your excitement, Silas. I mean, I know it's exciting. X squared minus x plus 1. And gather up your like terms. X squared minus x plus 1. Negative x, and negative x gives you negative 3x plus 4. What's the domain? Absolutely. When's the only time as I work through function operations with these two, when's the only time the domain will change? When there's a restriction, when there's, what could I do with, what operation could I do with f and g that would cause a domain restriction here? Well, why? Good job. Did y'all hear what he said? When you divide, if I did f divided by g, then I'd need to make sure g was never 0. It'd leave a number out, right? Yeah. If I did g divided by f, then I need to make sure f was never 0 because I need to make sure the bottom doesn't equal 0. Okay, let me show you. So same f, same g. If I did f divided by g of x, that would be x minus 1 squared over 3 minus x, right? Yes, Jerome.
I'm sorry.
It's okay.
I was looking at that poster and I don't believe it.
What poster?
That one right there.
About a kitten?
No, it's the one right next to it. It says
Let me back to the problem at hand. Domain restrictions here. Because f doesn't have any restrictions and g doesn't have any restrictions, but yet when I put them together in division, they do. And they do because why? This can't be 0. So what value, if I plugged in here, would make that be 0? 3. You can look at that one and tell, right? X cannot be 3. How do I leave that out of the domain? How do I write a domain that leaves out just the value of 3? Negative infinity to 3. Yes. Yes. Absolutely. Good job, y'all. If you ever leave out just one number, this is how you leave out just one number from a domain. If there's just one number you have to leave out, you do. But the other one didn't have, the other one, it stopped already at 4 and it didn't go past that anyway. That's why we just cut it off. All right.
All right.
Let's see. I'm going to redefine f and g.
What?
What's the domain of f? Oh, wait a minute.
Negative infinity to 5.
It's got to be greater than or equal to 0, right? All right, so if x is greater than or equal to negative 5, is that negative infinity to negative 5 or is that negative 5 to infinity? Negative 5 is the smallest it can be, and then it goes up from there, exactly. How about the domain on the absolute value function? You did the parent graph yesterday of absolute value. So think about the parent graph of absolute value. So we're talking about x. Not y, but x. Left to right. What's the domain? Absolutely. What is the domain of f plus g of x? So if I add them together, there's no like terms, right? I'm just going to have to leave it like that. You're absolutely right. Domain combined is -5 to infinity. All right, let me do a couple little composition things and I'll be done. Let me redefine f and g. Thank you, Jerome. So, I didn't really show you this, and maybe I should have. What if I put a number in there instead of an x? Exactly. So the first thing I need to do is I need to say, well, what's g of 3? Because that's what's going to be going in for f, right? Well, g of 3 is what? Which is what? So really what I'm finding is f of 3, right? Well, what's f of 3? Easy with numbers, right? Y'all remember this from Algebra 2? I know my Algebra 2 class spent an extensive amount of time on composition. It is. We did all of this. The only thing we didn't do in Algebra 2 is hit on the domain restrictions like that. Uno mas, because I told you a couple. And Jerome would be devastated if I didn't get to one more. No, we bought them. We supported Dick Pink.
But every teacher has one on, so it's like they told y'all.
No, they didn't tell us.
Well, they didn't tell y'all? You just support Russ. So that thing I got good one today?
Huh?
That thing I got good today?
What's the domain of F? You know what else is dripping? This math.
Yeah. Yeah. She would make something that sounds like something.
What's the domain of F?
Negative infinity.
Negative infinity to infinity. But what's the domain? We said negative infinity to infinity. How about the domain of G? Cannot be 0. What can't be 0? The bottom, so it's 1. So I got to leave 1 out. How do I leave 1 out?
Parentheses.
I had to leave 1 out. I had to take that one out of the domain. This x minus 1 can't be 0. So that means that x can't be 1. Because that would make the bottom 0. That's why I left 1 out. No, only the bottom. Find this and we'll be done. Did y'all get it? That means, Jerome, I'm plugging 1 over x minus 1 in for x. So I have 1 over x minus 1 squared minus 1, which is really just, I can take it to the top and the bottom, but I can't go any further because there's a minus there in the bottom, right? I would have to like FOIL it out, right? So what cannot be in the denominator there? 0. So my domain holds. There's the composed function. Why are you confused? On your homework. So let me show you this real quick. If I told you that I had this function, y equals x cubed plus 1 squared. And I told you that this was the result of a composition. So this is what I got when I did f of g of x. What's f and what's g? You got to look at it backwards now. That's it. Okay, so, right. Do you see that this was plugged in? So if I said x squared, right? So which one's what? One of them's x squared, one of them's x cubed plus 1. F is x squared, and g of x is x cubed plus 1.
Yeah, I get that.
They would just give you this. And they would say, this is the result of a function composition. What is f and what is g? They will all be pretty much that simple. Like, here's another one. I'll go back to that if you didn't get it. 1 over x cubed minus 5x plus 3. One function could be 1 over x, and then this is what you plugged in for x. Okay, you can make them as easy or as complicated as you want. Don't overcomplicate them. All right, your homework tonight.